Okay, so we are slowing way down so that basically by the end of this now extended deadline of April 24th is how long we're going to take to go through this packet. So we're doing, as opposed to what we used to do, which was multiple, we go through 2, 3, 4 pages in a day or in a week. We're slowing way down. So our goal for the week actually is just these first essentially 2 pages, front, back, and that's it. So we are only going to deal with ionic bonding this week. Then we'll do the same kind of thing next week, but with the covalent bonding. And then the following week, we'll get into the naming and stuff. So especially as I think some of the other teachers are starting to ramp up their work, I'm backing down a little. So that we're kind of all mentally okay is kind of what I'm thinking. So to begin with, if we're dealing with ionic, we need to go over valence electrons and charges, because that's the main thing for us. And then I want to do some actual practice. And then that should take us through the end of today. And then the other thing I do want to say is Friday's class really is just practicing more. So if after today you're like, I'm good, then you can send me a message and be like, I'm good, I don't need Friday's class. But if you want to come on Friday's class where we're just going to continue to practice before you do the thing that is an assessment grade, then that's cool. So I'll go over that at the end of class. So first off, as a review, you should know all of this. But how do we determine the total number of electrons for an element? The total number. Anybody shout it out.
Well, if it's like a neutral charge, then it's the same as a proton,
Atomic number.
is the atomic number.
It is the same as the protons. It is the atomic number, right? So it is the same as the atomic number on the periodic table. So that's for the total number of electrons. But we don't normally deal with the total number of electrons. We normally want just the valence electrons. So if I want just the valence electrons, how am I figuring that one out?
You look at the periodic table.
What on the periodic table is telling me that?
You look at
The group number.
Yeah, no, dang it. You look at the group number above it to tell you.
Okay, so you look at the group number above it, and what about those groups with the double-digit numbers?
You subtract it by 10.
All right, you drop that 1 off. Okay, so it's from the group number on the top. Okay, so we know those 2 bits of information. And then lastly, how do you figure out the charge when we need it? Because all these things are related.
The charge is basically based off of the octets. So basically, if it's less than 4, you add on, and if it's more than 4, you subtract.
Close. But it is based on the valence electrons, and the valence electrons are based on the group number, so it's also related to the group number.
If you're subtracting valence electrons, it becomes a positive charge. If you add them, it becomes negative.
Yes. So from this point on, you can basically just look at your periodic table as a reference, and we don't have to think so much more about that 4 rule or whatever, because you should have it written on your periodic table. So if you don't have your periodic table in front of you right now, you may want to have it or pull one up on your screen. But on the top of your periodic table, you should essentially have that stuff written out. If you do not have those valence electrons, and most importantly, that charge that I've got in red, you should write that on your periodic table literally right now.
Is that the one from yesterday, Ms. Baskin?
Yes, or from Monday. Yes, this is the one I did for you, Juan. Okay, so make sure you got that stuff on. And then if you've got your packet, if you actually turn to the next page, you see where it says task 1, that chart. I've got that chart in a Google Doc that we're all going to work on and fill out really fast.
How do I click on the link?
I'm going to put it in the chat window in just a second.
Oh, okay.
I'll go back in just a second, but okay. So I just sent the link. For the Google Doc. Does everybody have the periodic table stuff copied? Hopefully. Okay. So what I want you guys to do now is actually fill out this chart. Like, let's fill out this chart based on what we know. So I filled out the first row, chlorine, right, at Cl. Total number of electrons, like we said, it's the atomic number. Number of valence electrons is related to that group number. And then the charge at the top of group 17 for chlorine was -1. Negative means that it gained 1. So I think this is the chart, or this is the column here that people are going to be, that people get the most tripped up on, but it's actually the least important for what it is we're going to do. The valence electron column and the charge column are the most important for what we're going to do. So go ahead and start clicking into any box, right? Like, we don't all have to start at the top, but like, everybody try and get a couple of boxes filled in. And then once we get this all done, we can make sure all the answers are correct, and then you can write this into your own chart in your own packet. I'm always so amused by the random anonymous animals that Google assigns people.
Can you not see who is who?
No.
Oh, this is fun.
Well, when I just open share a document instead of share it with a specific person, it's just listed as anonymous. So
How do I check which one I am?
It's really hard to do it because I think it's actually different on your screen versus my screen. But
Who's Nyan Cat?
My favorite is Anonymous Cheetah.
Anonymous Cheetah. The Anonymous Chameleon's pretty fun.
Total number of electrons for fluorine. It's not.
Miss Baskin, it's not working for me.
That's okay. I mean, we're going to get it all kind of filled in here, and then you can just write it down into your own chart in your packet.
Shit.
Yeah, that wasn't on mute.
Oh wait, I'm not muted.
Miss Baskin,
Yes, dear.
I just want to say that I'm present for class.
I know, Trenton. I saw.
Okay.
Trent. Oh, who's
I
this?
miss you guys. I miss you.
Oh, Trent.
Oh my god. Oh Oh my
What
god.
the heck was
Bro.
that?
That's
The heck?
Going out our eardrums.
Is that what we're doing now?
Yeah, keep.
Hey, man.
Okay, so looking here, do we all agree that this first column is correct? Those are the correct atomic symbols?
Yeah.
Yes. Our total number of electrons, those should all be the atomic numbers. Yo, Dragon, what you doing? Yes, our total number, their second column is all correct. For the valence electrons, so 7, 1, 2, 7, 3. Let's fix that one. All right, sodium's valence electrons are incorrect. All right, so anything I'm highlighting needs to be fixed.
Well, I got you. Wait, so if that needs to be fixed, does the charge need to be fixed? Oh no, this loses.
Not necessarily, because it's the...
This loses.
Oh. I did something. There we go.
All right, so then -1.
How do I unhighlight it?
Ugh.
There we go.
Oops.
Gain.
It's up until somebody calls the cops and even then. And that will never happen.
Who's singing?
Can you go on mute, please?
Is
that Robin?
Loud.
Okay. So now do we fix it all? Yes. So potassium.
Put a 2. I mean, put a 3. What is it?
Loses, gains, loses. Sodium, that's still wrong.
Oh, never mind.
All right. Gopher's fixing it. Gains 2, loses 1, loses 4. All right. -1, +1, +2, -1, +3, +1. Not a plus though.
It's a minus.
Thank you, Duck. Oxygen. Huh? Okay, now this is correct. So everything in there is correct. So if you haven't done it yet, go ahead and fill out your paper chart
What?
in the packet.
What is it? I'm gonna go.
Hey, what packet is this?
Hakeem, it's the packet I gave you that Friday before. We haven't worked in it yet. It's the new one.
Miss Baskin, Naya Alpha's present.
Yeah, I saw you, Nye.
No,
I'll leave you alone.
no, go ahead.
Okay,
Bastard.
Yes, one.
I think carbon is wrong.
Well, it's in that column where it could gain or lose.
No, I'm talking about the total number of electrons.
Oh, well, I think
Isn't it just
somebody
9?
did that is it's 6.
No, it's 9. Oh, no, it is 6. Yeah, it's 6.
Carbon. Fluorine is 9.
Miss Baskin,
Yes, ma'am.
is total of electrons for oxygen, is that an 8 or a 3?
It's an 8, and whoever anonymous elephant is, it's their cursor is making it hard to see. But
Miss Baskin, I have a Zoom call with Mr. Freund now.
Okay.
Yeah, I have one too.
I'm gonna go.
Mrs. Baskin, are we
Miss
doing anything else after this?
What?
Are we doing anything else after the chart?
Yes. But
Miss
this is all
Baskin?
being recorded, so you can see it later.
Okay.
Yes, Robin.
Never mind, it's fine. I'm just going to Mr. Freund's class.
Okay.
Me too.
Okay, see you later. To the
Miss
five,
Baskin?
you will.
Miss Baskin.
Yes.
I really do think that some teachers forget to think about how much work we're getting from other teachers. Like, they just give a bunch of work just because.
Yes.
Yes, I also think teachers don't understand that, yes, we are home all day, but no, we cannot do all of the work in the whole entire universe.
Exactly.
That's what I'm saying.
I agree.
I'm like, we still have other classes. And we
And
still
Miss
have
Baskin, since you're like the head of our sophomore class, is there any way you can like work out something with the teachers? Because I don't think it's fair that the teachers mix up the time schedules and then we have to miss out on getting information because they didn't like use their time during their class period.
especially Gabrielle Dubose.
No. So here's the thing. Like, I'm not teaching classes when I normally have classes because I didn't want to do that, number one. And primarily, I didn't want to do any classes before 10 because I think that's dumb right now. But also, I teach 3 different classes. So I didn't want to follow our normal schedule. I also didn't, I saw no reason not to combine like my 3rd and 5th period into this same class. Like that to me makes sense. Combining my 2nd and 4th period into the same schedule also seems to make sense. I am trying to convince the other teachers to stop trying to hold classes when you normally have classes and just open it up to everybody. Be like, okay, so if you teach 6 classes of the same thing, we'll just do the same thing twice instead of 6 times, and then it's less work for you and it gives more flexibility for other people to be able to go do other things. My problem is at the moment, I am kind of maxed out on what I am able to do, and I have tried to coordinate things before any of this started, but nobody wanted to answer my emails, and so I said, okay, not my problem then. That's I bumped that problem up above me. So somebody else is supposed to be dealing with that, and it's going to take a week or so to coordinate, but it is being worked on.
I feel like for the vocal department, like the new teacher, Mr. Rogers, he's giving us completely new subjects to learn. Meanwhile, he can't even teach it right, so we don't know what we're doing. And it's like a pass-fail type grade. It's like if you do it, but you don't complete it all the way because you don't understand it, still fail. But if you do it, complete it, and it's correct, you get an A.
Yeah, I mean, my focus has basically been like trying to hound people to get old work done. And then as we move forward with new work, you know, I've slowed down what we're doing. I'm not doing half credit for late work anymore. I'm like, no. If you get it in, you get it in. I count it, you know, like that sort of thing, because we're all figuring out the best we can. But okay, so if you didn't get everything on this chart, you can at least look at it later, because I do want to go back and go over how to actually turn that information into Lewis structures. So here's the thing. You've got some space at the bottom of that sheet of paper where you wrote that chart, and you should kind of write these notes there. So if you already watched the Ed Puzzle video, which was due Monday night, I'm going over it exactly the same way that video did. So when you are trying to talk about an ionic compound, the first thing you need to do is remember that you will have a metal, and that the metal has to lose electrons. okay? And it has to lose all of its electrons. So if it has 1, it has to lose 1. If it has 2, it has to lose 2. If it has 3, it has to lose 3. But a metal is never going to have more than 3, and most of them only have 1 or 2.
We're writing this at the bottom, right?
Yeah, I would write this at the bottom.
Okay.
So that's the first rule. And then the second rule is the opposite for the nonmetals. The nonmetals have to gain until they get 8. So if they have 7, then they can only gain 1. If they have 6, they can only gain 2. And if they have 5, they can only gain 3. But they have to end up with 8. So metals have to lose everything, and nonmetals have to get to 8. Where it becomes tricky is if your metals and your nonmetals are not evenly matched. So if your metals and your nonmetals are not evenly matched, you can add more metals if you need more electrons. And you can add more nonmetals if you need to find more places for electrons to go. And I'll show you what that looks like in the examples.
Okay, Ms. Baskin, I got lost because I was in this reference.
Okay, we'll just write down what's on the screen. So since we're talking about ionic, we're showing transfer. And so we are always drawing an arrow from the electron in the metal to the nonmetal, showing it left the metal and went to the nonmetal. And then the last part, which is actually not quite as important, is putting the charges and the brackets and all that sort of stuff. So I'm more focused on can you draw the things with the arrows? That's the primary focus for today. So I'm gonna have you get all that written down, and then you can turn the page, and I'm just gonna do on the next page where it says example B1, B2, and B3, but I'm actually gonna do it on the board behind me.
Ms. Baxter, were we supposed to write that in a specific area, or could we just write it anywhere?
Just write it anywhere.
Okay.
Because we would have done a slightly different activity in class, which is what this packet was designed for, but c'est la vie.
Okay.
All right, I'll give it another minute or two for people to finish writing down what's on the screen.
Ms. Baskin,
Yeah.
can you scroll down a little bit? I can't see the last part of the last bullet point.
It says indicate how many of each element we used.
Okay, thank you.
Bridget, how you doing these days?
Ms. Baskin,
Yes, ma'am.
What page did you say go to next?
You literally just turn the page, and it's gonna. I'm doing those 3 examples.
Okay.
Okay. So, all right. So can everybody see me and my board back here?
Yeah.
Yeah. Okay.
Yes.
Cool. So our first one was sodium and chlorine. So sodium symbol is an Na. And how many valence electrons should it have?
1.
1. All right. So I'm going to use a little magnet there. It's got 1 guy. Okay. And what about chlorine?
7.
Okay. So it's got 7. So 1, 2, 3, 4, 5, 6, 7. So what you need to think about is how many valence electrons does the sodium have to lose?
1.
It has to lose 1, right? So sodium has to lose 1. And how many valence electrons does chlorine have to gain?
1.
It has to gain 1.
Perfect match.
All right. These are a perfect match. And so what we do is we tend to show an arrow drawing that electron from the sodium over to the chlorine, and I would move my little dot here.
Draw this.
So in your in that space, I would put this part right here, and then the whole talking about the brackets and everything, that would look like this. So sodium is now a +1, right? That's what we put on that chart on the other side. We put brackets for the chlorine, right? The brackets always go around the negative thing, and it's a -1. And I only had 1 of each, so that's how it looks. So that's what you write in that B1 box.
I can't see him, Miss Baskin.
What can you not see? Maybe the
Can you
NA.
scoot it like closer?
I didn't see it before.
About as close as I can get it with still having space for me. That better?
Yeah.
Just pull up pin her screen instead and it makes it bigger.
Miss Baskin.
Yes, Kayla.
So we supposed to be
Kaylin, you muted yourself. I can't hear you.
Oh, are we supposed to be drawing the dots on the sodium and the chlorine too?
Yes.
Okay.
Well, yeah, just up here, not, oh, I guess the video did show them down there. I don't. So I would say like showing the dots here up at the top. So you're showing the transfer, and then this is what ends up happening in the formula.
All right.
Yeah. Okay, I'm going to start erasing it to be able to get ready for the next one. So the next one, I tell you, that it's magnesium, and I say to begin with that it's 2 iodine. So how many valence electrons does magnesium have?
2.
2. So how many electrons does magnesium have to lose?
2.
Has to lose 2. Okay. But iodine has how many?
7.
7. All right, so 1, 2, 3, 4, 5, 6, 7. It says that you've got 2 iodines. Each one has 7. So how many electrons can a single iodine take in?
1. Just 1.
Just 1. So each one can take in 1. So does it make sense why you need 2 iodines paired with the magnesium?
Mm-hmm.
So it doesn't matter which electron you transfer to which iodine. But magnesium is going to give those 2 electrons over to the 2 iodines. So when we write this out, it's Mg with its +2 charge. But how many iodines do I have?
2.
2. So you put a 2 and then the brackets. Does that make sense?
Yeah.
Okay. So that's in the example B2, and then we'll do the reverse and have 2 of the metals and 1 of the nonmetals. So take another 30 seconds, make sure you have that drawn so I can do the last one, and then we'll call it a day. Okay, so for the last one, in example B3, I tell you 2 sodiums and 1 oxygen. So and just like the first one, each sodium has how many dots?
1.
1. And they each need to lose, right? So each will lose 1. And oxygen is going to have how many?
6.
All right. 1, 2, 3, 4. And that oxygen needs how many more?
2.
It needs 2 more. So you have to pair the 2 sodiums with the oxygen because you can't just give oxygen 1. It's not going to be happy. And then since you have 2 of the sodiums, it would be 2 of the Na plus, and then the oxygen in the brackets. And that's it. And that's what you would do for B3.
So, Miss Baskin,
yeah,
you wouldn't put plus for the sodium. You wouldn't put +2 because you've already said that there's 2 of them. So you would just put 1.
Yes.
Okay.
So each one is a +1, but there are 2 of them. Yeah. And that's it. So examples B4, B5, and B6 are the same thing, except you have to figure out how many of each one you need. And then on the next page, there's 3 more practice for ionic. And then on the page after that, there's 4 more practice for ionic. That's what I'm going to do on Friday and work with you guys to practice all of these. And that's it. This is the skill for the week that I want you to know how to be able to do. So if you think you are good with this, then I don't need to see you on Friday, but you should communicate that to me and say, I'm good. There is, again, no calm this week because you can't actually draw, like, this is not the type of problem that you can do on calm. So instead, there is another of those wiser worksheets where you can do stuff around this. That link is on the sheet. And if you think you know how to do it, be like, I'm good. I'm going to go ahead and try that and be done for the week. But that is the ultimate goal for you to be able to do by the end of the week. So you communicate to me. If you need to be here on Friday, we'll just practice, practice, practice. If you don't, then you can move on to the assessment piece with that wiser worksheet and call it a day. I will post the next Edpuzzle video for Monday night later today, and that's it. So if you have questions, you can hang around. Otherwise, we're good for class.
When's the wiser thing you do?
It'll be due by Monday night.
So the wiser.
I'm sorry. What's the wiser thing? I missed that.
It's on the weekly plan. That's instead of doing calm, you're doing this wiser worksheet instead. It's a link.
Last time.
So that's not an assessment.
It will count as an assessment grade, but like a 10-point assessment, just like the last one.
But is it? Oh, so it's a different one. It's not the one from last.
Yeah, it's a different one. Yeah.
Okay.
Yeah. So, and I'll send I will clarify all of that in Remind communication as well as email, or in class on Friday. But okay.
So right now we just have an Edpuzzle that's going up tonight. And then the other worksheet, which is an assessment grade, needs to be done by Monday after the review on Friday.
Yes.
Okay, great.
Cool.
Miss Baskin, you want us to finish before 5 and 6, right?
Yeah, I would say try and finish 4, 5, and 6. And then if you think you don't need to come in on Friday, you can send me a picture and be like, did I do this right? And if you did it right, I'll be like, yeah, you're probably good. Okay. All right.
Miss.
Yes.
Did you? I was in the bathroom. Did you send a link to the Weisper, however you say thing?
No, I didn't. It's in the weekly plan, that Google Doc that I sent out at the beginning of the week. It's in there.
Okay.
Miss Baskin.
But technically, I wasn't like quote unquote assigning it until Friday. So.
Okay.
Yes, Takara.
I wasn't there for like the last Zoom last week. So I'm kind of confused on like what like the assessment and stuff was. Can you like help me figure that out?
Yeah, for right now, we're using, because we can't really do quizzes, I'm using these weekly Wiser worksheets as like small little assessment grades each week. And the links are in those weekly plan Google Docs that I send out every Sunday.
Okay.
So, Juan, what did you set as your background?
Oh, that's the Duke Theater.
Oh, there it is. Okay.
That's what that is?
Yeah,
Okay.
Y'all, Leanna's asleep.
that's okay.
So I
All right, so I'm gonna go ahead and end the class so I can process the video and get it posted. And if anybody has any questions, you can just send me a message or pop into office hours sometime, okay?
Miss Baskin, am I just gonna get on the same Zoom call at 12?
Yeah, at 12 o'clock it'll be the same. It's the same link, but I've got to close this. I have to technically, because otherwise it won't process. Yep.
Bye,
Okay.
Miss Baskin.
Great, thank you.
Guys.
Bye, Miss Baskin.
Baskin, thank you.
Shut up.
Well, what pretty flowers, Noelle.